This is our EEE 250 final project prepared by Mark Rodriguez, Jenna Kleindust, and Amy Cooper, discussing residence time. Before we do any calculations, there are a few definitions that are important to know for the assumptions of our system. Residence time is the amount of time something spends in a stock, or the turnover time. A well-mixed system is when the concentration is uniform throughout the system. A system is in steady state when the stock doesn't change over time, so that the input is equal to the output.
To calculate the residence time of the system, we will use the following formula. Residence time equals volume divided by flow. With this formula, we are assuming that the system is well mixed and the flow in is equal to the flow out because the system is in steady state. To demonstrate the concept of residence time, we are going to use a pond system that was polluted, and remediation methods are being put into place to pump the pollutant out of the system and replace it with clean water. For this demo, we will assume that the volume of the pond is 10,000 liters and that the flow in and out are both 50 liters per hour. Here is a photo of the vessel we used to represent the polluted pond in our simulation.
We began the simulation with a high concentration of green polluted water, and over time we are flushing out the pollutant with clean, clear water in order to measure the residence time of the pollutant in the system. As you can see, at the start of the simulation, the water will have the highest green pollutant concentration. Later in the simulation, our pond water is now lighter than initially, which indicates that there is green pollutant leaving the system. At the end of our simulation, the pond water is rid of the green coloring and is now clear, showing that the pollutant has completely left the system and has finalized its residence time. When we plug our assumed values for the pond system into the residence time equation, we find that the pollutant's residence time in the system was 200 hours. After watching this video, we hope you better understand the application of residence time in a real system.